everybody, and today we are going to be discussing our last type of factoring. There are still other types of factoring when we get into cubics, but that is something that you'll discuss next year. We only deal with factoring of quadratics. Now, if you'll take a look, you'll see that there is an a in front of x squared. That is a leading coefficient. Anytime our leading coefficient is not 1, we have to do something a little differently. So let's go ahead and take our first look. Our first problem is 5x squared plus 8x plus 3. You'll notice that in front of x squared is a 5. Now, anytime I see a number that's other than 1 in front of my x squared, I always look for a greatest common factor. Every time you start a problem, you need to start with greatest common factor. So this is 5 times x times x. This is 2 times 2 times 2 times x. And this is just 3, because 3 is prime. You'll notice that of the three terms, they don't share all the same thing. Therefore, there is no greatest common factor. So what we do is we are now going to create a different process for solving. So if you'll notice, this box looks vaguely familiar. This is the box that we did when we were multiplying binomials and trinomials. So we are actually going to work our way inside out this time to get the factored answer. So the first thing we're going to do is we're going to put 5x squared in the top left box. That is our first term. Now we're going to take the last term plus 3 and put that in the bottom right hand corner box. For step 2, we need to find the factors of 5 times 3. We need to multiply 5 times 3, and when we do, we get 15. So I'm looking for the factors of 15 that will add to a positive 8. So let's see, the factors of 15 are 1 and 15, and 3 and 5. I don't seem to think there are any other factors of 15. So 1 plus 15 is 16, and 3 plus 5 is 8. That means my two factors are 3 and 5. Now what we're going to do with this 3 and 5 is we're actually going to put it in the box. So we have 3x and 5x. Now I could have switched it and put 3x in one box and 5x in the other. It doesn't really matter. So step 3 says we are going to find the GCF. Look, that comes up again and again and again. That was our first video on factoring. We need to find the greatest common factor for each row and each column. So take a look at this row right here. We have 5x squared and 3x. The prime factorization of 5x squared is 5 times x times x. The prime factorization of 3x is 3 times x. So the GCF here is x. So we put an x right here. All right, now I'm going to delete this out of the way. And let's do our next row. We have 5x plus 3. So I have 5 times x, and I have 3. Now you'll notice there is no GCF here. So we still have to have a placeholder. So we're going to put plus 1. All right. Now we begin with the columns. So let's work on 5x squared plus 5x. So the GCF, or prime factorization of 5x squared is 5 times x times x. The prime factorization of 5x is 5 times x. Notice they share a 5 and an x. So 5x goes here. All right, so let's delete this. All right, and now we're going to find the GCF of 3x and 3. The prime factorization of 3x is 3 times x. The prime factorization of 3 is just 3. So what they share is a 3. Oops, I'm going to get it in the red color that we've been using. There we go. So what you'll notice is we have worked our way backwards for the multiplying polynomials. All right, so what we'll have to do here now is what we do is we take the GCFs. This is going to be our first factored form, x plus 1. And this is our second factor, 5x plus 3. So when I factor out 5x squared plus 8x plus 3, I get the answer x plus 1 times 5x plus 3. Now we can always multiply these back together to make sure we did it correctly. 5x times x, 5x squared. 3 times x, 3x. 5x times 1 is 5x. and 1 times 3 is 3. So what we have done is we have done the opposite of our box method for multiplying polynomials. We have gone in the other direction, the inverse, if you would. So you remember when I told you that you would really have to know how to multiply polynomials in order to factor? Well, here you go. All right, so here's some practice problems. If you feel comfortable, go ahead and start these. Otherwise, watch and work with me. All right, so first thing I look for is a greatest common factor. There is no greatest common factor between 3x squared, negative 8x, and 4. So what I do is step 1, multiply 3 times 4. Well, step 1 is make the box, but I've already done that for you. So 3 times 4 is 12. I'm looking for the factors of 12 that will add to a negative 8. So what I'm looking for here is like negative 1, negative 12, negative 2, negative 6, negative 3, negative 4. So I'll have to move this box down just a smidge. There we go. So these are the factors of 12 that will add to a negative number. This results in a negative 13, this results in a negative 8, and when I add these, I get negative 7. So my answer is negative 2 and negative 6. So the top left box is our first term, 3x squared. Our bottom right box is the last term, plus 4. And the middle two, the diagonal, is going to be negative 2x and negative 6x, because those are the factors that will multiply to a positive 12, but will add to a negative 8. So now it's our job to find the greatest common factor for each column and each row. So the greatest common factor for this row is going to be simply x. Now let's do the prime factorization of negative 6x and 4. So we have 2 times 3 times x, and 4 is 2 times 2. So they both share a 2. Now we have to be careful here. This is actually going to be a negative 2, and I'll explain why in just a moment. All right, now the prime factorization of 2x is 2 times x. The prime factorization of 4 is 2 times 2. So this is also going to be a 2, but it will be a minus, and I'll explain why in just a minute. Now for this column, the prime factorization is 3 times x, and this is 2 times 3 times x. So we share a 3 and an x. So what you'll see here, I'm going to go ahead and delete the prime factorization here. Okay, you'll see that our factors should be x minus 2 and 3x minus 2. Now, remember I told you I would explain why we had to have a negative 2 here and here? Well, when we multiply it back in, look, negative 2 times negative 2 results in the positive 4 that I need. If I had written plus 2 here and plus 2 here, I would still get the plus 4, but the problem would become when I multiply x times the 2, I need a negative 2x. So when I have a positive c and a negative b, I know that my two factors are going to have negative in them. If you're ever not sure, go ahead and multiply it back out and see, did I do this correctly? Okay? Now, 15x squared plus 1x minus 2. Now, there's no greatest common factor here, so 15 times a negative 2 is negative 30. Now, remember, when I have a number that is negative, the signs are going to be different. Remember that in order to multiply to a negative number, the two factor signs must be one positive and one negative. All right, so what we have here is 1 and 30, 2 and 15, 3 and 10, and 4 and 5. So if, not 4 and 5, excuse me, 5 and 6. So if I did negative 5 comma 6, negative 5 times 6 gives me the negative 30 that I need, but when I add them, they will equal the plus 1. So the top left-hand box is 15x squared. The bottom right-hand box is negative 2. And my factors are negative 5x and positive 6x. All right, so we are going to go ahead and figure these out. Greatest common factor, so 3 times 5 times x times x. This is negative 1 times 5 times x. This is negative 1 times 2. And this is 2 times 3 times x. So I just went ahead and did all the greatest common factors for all four squares. Taking a look at this row right here, I share a 5 and an x. so 5x belongs here. I share a 2, so the plus 2 goes here in this row. Now looking down my column, I share a 3 and an x, so there's a 3x here. And then in here, 5x and 2 don't have anything in common except that they are both negative, so this would be a negative 1. So if I were to factor this out, it would be 5x plus 2 times 3x minus 1. Okay? And you can always go back and double check and say, did you multiply this correctly? Alright, I want you to try the first problem on the left and then unpause when you're ready to check your answer. Alright, so if we take a look at the answer, 4x minus 5 times x minus 5, you may also have written it x minus 5 times 4x minus 5. That's okay. The commutative property of multiplication says we are allowed to do that. Now remember, you might have made the mistake of you forget to put the negatives here and here. The reason is when I have a positive c but a negative b, both of the factors must have a negative inside of it. Now on the next one, I guess they're not numbered, there actually is a greatest common factor of 2 for all pieces. So I can factor out a 2 and create a new, easier problem. Oops, excuse me, I did not mean to move that. So I need to move this box down just a little bit. Okay, now what I will factor is the 6x squared plus 13x plus 6. So 6x squared plus 6. So the factors of 36 that add to 13 would be 9 times 4. So I get a 9x and a 4x. So go ahead and find the GCFs here and write your final factored form. Now you may have gotten to this part and you wrote your answer like this. However, there's one thing you may have forgotten. Remember that the greatest common factor needs to go out front. If I were to multiply all of this back, then I would get my original problem that I started with up here. Otherwise, without the 2, I would only end up with the 6x squared plus 13x plus 6. Alright, so we have one last problem for today. 4x squared minus 23x minus 35. Check your greatest common factor and then begin finding the factors. Alright, so the factors that multiply to negative 140 but add to negative 23 would be negative 28 and 5. Alright, so we put that here, prime factorization. That incorrectly. Let me fix that. So we share an x here. We share a negative 1 and a 7, so negative 7. We share 2 times 2 times x, so 4x. And we share a 5. So my answer here is 4x plus 5 times x minus 7. And that is the factored form of the trinomial 4x squared minus 23x minus 35. Alright, that is all the types of factoring that we have in this grade. Remember that we're going to be using these when we talk about the factors and solutions of quadratics after our next test. Okay, so be prepared. If you have questions, don't forget to ask them. I'll see you guys later.